Remember those sci-fi films, where getting across town just meant hailing a flying taxi?
Waving down a cab in the sky. Seems like pure fantasy.
Exactly. But, well, that future. It might be arriving a lot faster than we think.
Uh-huh.
So today, we're doing a deep dive into electric air taxis and this whole big idea of urban air mobility.
Right.
We've pulled together a bunch of articles, some research, expert notes, basically giving you the shortcut to getting up to speed on this. It's pretty groundbreaking stuff.
Absolutely. And our mission today really is to cut through some of the hype. Let's look at the actual engineering, the regulations, which are huge, and the city planning needed to make this real for you.
Okay.
We'll unpack what these vehicles are, who's building them, the big hurdles they face getting approved, where they might fly first, and how they could actually fit into our cities.
Yeah, because it raises so many questions. What does this mean for, your daily commute? Or how we get critical supplies across cities, or even emergency response? Let's get into it.
Let's do it.
Okay, so kicking things off, basics first. When we say electric air taxis, what exactly are we talking about? What's the core tech?
Right. So at the heart of it, we're talking about eVTOL aircraft.
Yeah.
That stands for electric vertical takeoff and landing.
eVTO.
Got it. Yeah. Think of them, maybe, like a new kind of helicopter. But electric, quiet, clean. They use batteries and electric motors instead of, those loud fuel-burning engines.
Ah, okay, so quieter is a big part of it.
A huge part. And they often have multiple smaller rotors, not just one big one, typically carrying, say, 1 to 5 passengers or cargo. They're really designed to tackle problems like the noise and pollution from regular helicopters in cities.
So kind of like the electric cars of the sky, or maybe even big drones that can carry people.
That's a good analogy.
Yeah.
Yeah, both work. The key is the electric power and the vertical takeoff. But maybe let's quickly highlight the main differences compared to a standard helicopter.
Good idea. Lay it out for us.
Okay, so engine, eVTOLs use electric motors and batteries. Helicopters use fuel, turbines, or pistons. Big difference there.
Right.
Noise, massive difference. eVTOLs are designed to be much, much quieter. Some are aiming for dishwasher level noise from the ground. Helicopters, very loud, that chopping sound.
Yeah, you definitely hear them coming.
Emissions, eVTOLs have 0 during flight. Helicopters burn fuel, so carbon emissions.
Okay. And complexity.
Well, it's different. eVTOLs have simpler electric motors, but potentially more of them. Helicopters have incredibly complex gearboxes and rotor systems. So mechanically simpler in one way, but systemically complex with the electrics and controls.
Interesting. So the eVTOL is the flying machine itself, but you said it's part of something bigger.
Exactly. The eVTOL is the vehicle, but it operates within this larger concept called urban air mobility, or UAM.
UAM. Okay.
Yeah. UAM isn't just the aircraft, it's the whole network, the big idea. It includes the eVTOLs, yes, but also the places they land and take off from vertiports.
Vertiports, like mini airports.
Sort of. More like landing pads, often on buildings, with charging stations. UAM also includes the air traffic systems needed to manage them, the booking platforms, the regulations, how it all connects with existing transport. It's basically adding a new layer of transportation in cities.
A whole new layer. Wow. Is that just for people or?
Oh, definitely not just people. That's a key point. UAM could be huge for things like medical deliveries, organs, blood, really fast.
Oh, wow.
Emergency services too, police, fire, and even cargo delivery for certain things. Actually, a lot of cities might test UAM with cargo or medical flights before they let passengers on board.
That makes sense. Prove the system first.
Right. It's a smart way to build trust and work out the kinks. And just to zoom out even further, UAM itself fits into an even bigger picture. Advanced Air Mobility, AAM.
Okay, another acronym, AAM.
Yeah, sorry. AM is the broadest term. It covers urban flights, but also regional trips, maybe between nearby cities, and even services to remote areas. So AAM is the umbrella for all of it.
Okay, let me try to recap that, make sure I've got it. eVTOLs are the actual electric aircraft, quieter vertical takeoff. UAM is the whole system for flying inside cities, planes, ports, rules, the works. And AAM is the really big vision, urban, regional, everything electric in the air.
You nailed it. It's definitely more than just a flying car. It's a whole new ecosystem.
Right. Okay, now this is where it gets really interesting for me. Who's actually building these things? And, the big question, when might we actually see them flying around?
Yeah, the race is definitely on. And some companies are making serious progress. In the U.S., Joby Aviation is probably one of the furthest along in terms of getting certified by the FAA. They've passed 3 of the 5 main stages.
3 out of 5, okay.
Yeah. They got backing from Toyota, used to work with Uber. Their aircraft takes a pilot plus 4 passengers, uses 6 tilting rotors, range is about 150 miles, speeds up to 200 miles per hour.
Pretty impressive.
They are. And the really big news with Joby is they're actually delivering their first production aircraft to Dubai. The plan is to start service there in early 2026.
2026 in Dubai.
Wow. Yep. Also the U.S., there's Archer Aviation. They're working with United Airlines, focusing on those airport shuttle routes we talked about, like Manhattan to JFK or downtown L.A. to LAX. They're aiming for commercial flights in around 2025, maybe 2026.
Okay, so similar timeline. What about outside the U.S.?
Definitely. Over in Germany, you've got Volocopter. Their design looks a bit more like a large drone, really. It's for 2 people, aimed at shorter inner-city hops. They're very ambitious, targeting first commercial flights by 2024 or 2025. They specifically want to be visible during the Paris 2024 Olympics.
The Paris Olympics, as in next year?
That's the plan.
Yeah.
A high-profile demonstration, at least. Then you've also got Vertical Aerospace in the UK, their VX4 model, targeting maybe 2028 to 2030. And Eve Air Mobility in Brazil, which is part of Embraer, the big aircraft manufacturer. They're signing deals globally, so it's a real international race.
It certainly sounds like it, but okay, the companies are building the planes, that's one thing. But this can't just be a private company thing, right? Governments, cities, they must be heavily involved.
Oh, absolutely. You can't just launch a new air transport system without massive government buy-in and coordination. It's essential.
Right.
So in the U.S., for example, the White House and the FAA launched the National AM Integration Strategy in September 2025. Basically a pilot program.
Okay. What does it do?
It aims to speed things up by getting companies and cities working together in real-world settings, testing how these things actually behave, building public trust, figuring out the practicalities. It's crucial.
Makes sense. Need those real-world tests.
Exactly. And Dubai, which we mentioned with Joby, their plan is a really clear example of that kind of integrated approach. They're not just buying aircraft. They're actively planning and building the vertiports, setting up the air traffic control systems needed. They want to connect key parts of the city from the air, starting in early 2026. It's a very deliberate top-down strategy.
So it's not just talk. Trials are happening. First flights could be, wow, maybe next year in Paris, then Dubai, soon after. What stands out most to you about how fast this seems to be moving?
I think it's the convergence. The battery tech got good enough, the electric motor tech, the computing power for controls. It all kind of hit a critical point. But now, the focus is shifting hard to the integration and regulation. That's the next mountain to climb.
Right. Let's talk about that mountain. So planes are getting built, trials are running, but getting these things actually approved to fly paying passengers around cities safely day in, day out, that sounds like a huge obstacle course. Is that fair?
That's absolutely fair. Many people think the engineering is the toughest bit, but arguably the regulatory pathway is even more complex. Aviation safety standards are incredibly high. For good reason.
Yeah, you don't want things falling out of the sky.
Exactly. And introducing a totally new type of aircraft, flying in new ways in complex urban environments, it creates massive challenges for regulators. We're talking about basically 6 critical areas they need to be satisfied on.
6 areas. Okay, what's the first one?
The first big one is type certification. This is where authorities like the FAA in the U.S. or EASA in Europe formally approve the actual design of the aircraft.
Yeah.
Is it inherently safe to fly?
Okay. What do they check?
Everything. Structural strength, how it handles, but especially the new stuff. Redundancy is huge. What happens if a motor fails?
Or 2?
Battery safety is critical, preventing fires, overheating, what they call thermal runaway.
Right, you hear about battery fires sometimes.
Precisely. They also look at the flight control systems, how the pilot interacts with it, even cybersecurity, could someone hack it? And because eVTOLs are so new, they often don't fit existing rules. They fall into this special powered lift category. So regulators are having to write new rules like the FAA's Advisory Circular AC 21.174. It's about proving the design itself is rock solid.
Okay, so that's the design. But once the design is approved, that's not the end. Right, then you have to figure out how to actually use it.
Exactly. That leads to operational certification.
Yep.
This is all about, can this approved design fly safely in the real world, day after day?
Okay, so what does that cover?
It covers pilot training and licensing. You need new programs for eVTOL pilots. It covers the actual flight rules for cities. Where can they fly? When? How high? How do they interact with helicopters, planes, drones? It covers noise regulations in practice and maintenance procedures. How do you keep these new aircraft airworthy?
So like defining the invisible roads in the sky.
Pretty much, yeah. Both the FAA and EASA are working hard on defining these urban air corridors, figuring out emergency procedures, shared standards.
And linked to that must be safety and risk, right? What if something goes wrong?
Absolutely central. That's safety and risk assessment. Because the designs are novel, there are new potential risks.
Hmm.
Maybe a failure of the propulsion system affecting multiple rotors, battery failure modes, bird strikes hitting smaller rotors, software bugs, even just pilot error in a new type of machine.
So how do they address that?
Redundancy, redundancy, redundancy. That's the mantra. Every critical system needs backups. Extra rotors that can take over, dual battery systems, sometimes even ballistic parachutes that can bring the whole aircraft down safely. Regulators need to see multiple layers of protection for every potential failure.
Okay. Now, you mentioned noise before. For people living in cities, that's got to be a massive concern. How are they tackling the noise issue specifically?
It's definitely one of the biggest potential showstoppers for public acceptance. So noise and environmental impacts are heavily scrutinized.
Right.
Regulators look at noise levels during takeoff, hover, landing, cruising, but also the type of noise. Is it that annoying high-pitched whine? That's called tonal noise,
Yeah.
and it could be more bothersome even if the overall decibels aren't that high.
Ah, interesting. It's not just loudness.
No. And they're trying to set limits based on public tolerance. This means planning flight paths very carefully. There are studies, like one NASA funded in the Dallas-Fort Worth area, mapping potential noise exposure to figure out the quietest roads, maybe over industrial areas or highways, avoiding residential zones as much as possible.
Using data to plan quiet skies.
Essentially, yes. And beyond noise, they also look at the environmental side, energy use, battery life, the CO2 impact of making the batteries, recycling them. It's a broad assessment.
Okay. And you mentioned 6 areas. What are the other couple briefly?
The other key areas are infrastructure and airspace integration, making sure vertiports are safe, and these things fit into the existing air traffic system and international rule harmonization, making sure rules in the US, Europe, Brazil, elsewhere are broadly compatible, so aircraft certified in one place can eventually fly in another. The FAA even put out a roadmap in April 2025 to help navigate this global certification puzzle. It's all interconnected.
Wow. Okay, that is a lot of hurdles. So, given all that and the need for new infrastructure like vertiports, where are we actually likely to see the first flights happening? It can't be everywhere at once.
No, definitely not. It'll be a very targeted rollout. They'll start where it's safest, most practical, and frankly, where it makes the most business sense initially.
Makes sense. So, what are those likely first use cases?
Well, the most obvious one, which we touched on, is airport shuttles. Flying between major airports and city centers. Think LAX to downtown LA or JFK to Manhattan.
Why there first?
Several reasons. Airports already have air traffic control and security infrastructure. The roads are pretty fixed and predictable. There's huge demand from travelers who hate traffic and are often willing to pay a premium to save, an hour or two. It just ticks a lot of boxes.
Okay, airport runs. That makes a lot of sense. What else?
Second, probably point-to-point flights over really congested areas. Imagine flying directly over the worst traffic jams, like maybe across the bay in San Francisco or over Sao Paulo's gridlock.
Just hopping over the traffic.
Exactly. It offers massive time savings for a relatively short distance. It's about using that third dimension intelligently, where ground transport is just awful.
Right. And what about the non-passenger stuff?
That's likely to be very early, too. Medical, emergency, or cargo flights. Delivering an organ for transplant, critical medical supplies, maybe emergency response.
Why would that be easier to start with?
Well, the urgency can sometimes help streamline the regulatory side. There's less liability involved compared to carrying passengers initially, and it's a fantastic way to prove the aircraft's reliability and performance in demanding situations. So most experts think airport shuttles and these critical delivery missions will be the pioneers. We see Joby targeting LAX routes with Uber, Dubai testing tourist flights. It fits that pattern.
Any other early possibilities?
Maybe some tourism or scenic routes. They often face slightly less stringent operational rules initially and can be a good way to build public awareness and acceptance. See it flying, get comfortable with it.
Okay, so it starts specific airports, cargo, maybe scenic spots. But the big vision is integration, right? Making it just another transport option. How does that future actually look like day to day for a passenger?
Yeah, seamless integration is the ultimate goal. For this to really work at scale, it can't be isolated. So we're talking about vertiports located near major transit hubs.
Okay, like on top of train stations.
Exactly. Or next to metro stops, major bus terminals,
Mm.
with easy connections, escalators, walkways so you can step off a train onto an eVTOL or vice versa, making that first mile, last mile journey smooth. Companies like Vertical Aerospace in the UK are already partnering with airports and train companies on this.
Cool. And booking it.
Through app integration, you'd likely book an eVTOL ride using the same apps you use for ride-sharing now. Real-time info may be bundled with your public transport pass. One app for the whole trip.
Nice. Okay. But how do you stop the sky from becoming chaotic?
That's where dedicated airspace corridors come in. Think of them as predefined highways in the sky.
Invisible lanes.
Basically, yes. Often routed over industrial areas, maybe following existing major roads using specific altitudes. GPS-defined pathways to manage the traffic flow, prevent conflicts, and crucially, keep the noise away from where most people live. NASA and the FAA are actively developing the UAM traffic management systems needed for this.
Sophisticated air traffic control just for cities?
Pretty much. And all this needs strong government partnerships to define the routes, manage noise, set the rules fairly. Plus, policies and zoning from cities to actually allow vertiports to be built in useful locations, like Dubai is already doing.
So let me try to picture it. I leave my house in the suburbs, maybe walk to a small local vertiport, hop in an eVTOL, fly for, say, 12 minutes over traffic into the city center, land on top of the main train station, walk down an escalator, take a quick subway ride to my office, all booked on one app. No car, no traffic stress, way fewer emissions.
That's the vision. Connected, efficient, cleaner urban travel.
It really does paint a compelling picture of what could be coming.
Wow. Okay, so this deep dive has really shown just how much is going into making this electric air taxi idea a reality. It's way more than just cool-looking aircraft.
Oh, absolutely. The complexity is immense. From the fundamental eVTOL engineering through that incredibly tough regulatory gauntlet we talked about to the city planning needed for integration. It's a huge, multifaceted effort. And it's moving surprisingly fast.
It really is. The pace is kind of astonishing when you lay it all out.
It is. And what strikes me is the level of precision and planning required at every single stage. Designing for safety, proving that safety, figuring out how these things operate quietly and efficiently alongside everything else in the sky. It's a massive undertaking.
So as we wrap this up, thinking about everything we've discussed,
Yeah.
what stands out most to you personally about this emerging technology? Are you like ready to jump in an air taxi tomorrow if you could?
Well, maybe not tomorrow, but I'm definitely excited by the potential. What stands out is the possibility of genuinely rethinking urban mobility. Yeah. And for you listening, what strikes you the most? Are you ready for an air taxi commute? And maybe looking further out, what are the big trade-offs we need to think about? Balancing maybe energy use versus noise, or the initial high cost versus making this accessible for everyone eventually. What do you think are the critical questions we need to answer for these sky commutes to really, truly take off for all of us?